Hello everybody, welcome into another lesson. So today we are going to talk about intersections and union of sets. So this gets more into number theory than it does algebra, but this is taught in a lot of Algebra 1 courses. So if you're taking Algebra 1 now and you need help with this, or you will be taking an Algebra 1 course in the future, this is for you. So we have first what's called the union of sets. Let's begin with the sets here. You have set A, usually is denoted by an uppercase letter, the set name. And then these weird curvy brackets you see is set notation. And then the numbers listed in those curvy brackets, those are the members of the set. So set A contains 1, 2, 3, 4, and 5. Then set B contains 2, 4, and 6. Then set C contains 7 and 8. So, those are sets. To find the union of a set, it's quite easy. When you find the union of two sets, you're just combining both sets together. So you're putting all the members of one set together with all the members of another. So let's say I want to find A is in union with B. Find the union of a set. The union of a set is represented, the name of the set, U for union. You could think of it as U for union, if that makes sense. So one set is in union with another. We want to find what that's going to be. So if we take A and unite it with B, the union of A and B, you're going to take all the members of A and unite it with all the members of B. So, though you may have some elements of a set that are not in the other set, they'll be part of the united set because all of them are coming together. So, of course, build your set notation. A is in union with B. Alright. Let's see, look at the members of A. You have 1, 2, 3, 4, 5. Then B, you have 2, 4, and 6. Well, they have a 1, so you're going to get a 1 for the set. They both have a 2. Now, if the same number occurs in both sets, you only list it once. But you want to list the results, the set members, in numerical order. That's very important. Only set A contains a 3, but still the combined set will have a 3. And then they both contain a 4, but you only got to list it once. So you'll have so far 1, 2, 3, 4. And then only set A contains 5. Well, when you unite them, you'll get 5. And then only set B contains 6, but when you unite them, you'll have 6 as a member of the united set. So the answer to set A in union with set B is you get the set of 1, 2, 3, 4, 5, and 6. You've just combined all the elements of A and B together into one set when you take a union. And you only have to list each number once. So that'll help you out. So that's A is in union with B. Okay. Now next, let's do B in union with C. So let's unite sets B and C. What would that look like? So build your set notation. Well, let's see. In B, you have 2, 4, 6. Then in C, you have 7 and 8. You have no repeating elements, so that makes it nice, and it seems to be in numerical order already. So you're just going to get the set of 2, 4, 6, 7, and 8. So this B united with C gives you, B in union with C will give you the set of 2, 4, 6, 7, and 8. That's what you would get. So union, you're just simply combining elements together. Alright, then we're going to take A and unite it with C. we'll take A and unite it with C. So in A, you have 1, 2, 3, 4, and 5. In C, you have 7 and 8. Well, there's no repeating numbers, and they seem to be in numerical order, so you'll literally, when you unionize a set, you'll get 1, 2, 3, 4, 5, then 7, then 8. Those will be all the members of your set when you take A in union with C. You'll get 1, 2, 3, 4, 5, 7, and 8. And yes, if you're wondering, you can do a three-way union. You certainly can. Let's say we wanted to take A is in union with B is in union with C. Well, what you got to do now is unite all three sets. That's all you have to do. So you're uniting all three sets. So 1 is exclusive to A. So yeah, you'll have 1. Now 2 occurs in both A and B, but you'll have 2 in the united set. 3 only occurs in A, but you'll have 3 in the united set. 4 occurs in both A and B, but you'll still have 4 in the united set. You only got to list it once. You'll have 5 in A, but you'll have that in the united set. You have 6 only in B, but you'll have that in the united set. And then 7 and 8 both only occur in C, but they're members of the whole united set. So the result of set A in union with set B in union with set C is going to be the set of 1, 2, 3, 4, 5, 6, 7, and 8. That would be the union. So you're basically, all you're going to do is combine sets together. Pretty simple for a union. We're going to do some union problems real quick, and then we'll move on to intersection of sets. So let's see. We will find, let me write this in a different color since I'm doing the master problem here. Find A union B when, all right. So for these few problems here, we're going to do the union of two sets. And we only have 2 sets, so that's going to make life a lot easier. We'll find A union B when set A is equal to the set of -2, -3, -4, and then set B is equal to the set of -3, -2, -1, and 0. So what we want to do is find the union of sets A and B. Well, start with your smallest number that you can find. Your smallest number is -4. You only find that in set A. We're going to take A and union with B. That'll give you the set of -4 to start with, because we want to go in numerical order. Now, -3 you find in both sets A and B, but you only got to list it once. You will find -3. You'll also find -2 in sets A and B. You only got to list that once. You find -1 and only in B, but since it's a union, it'll be included. And you only find 0 in B. So that'll also be included since it's a union. So the unionized set of A and B, when you unite the two sets, you get the set of -4, -3, -2, -1, and 0, because you unite all the numbers. Alright, that wasn't too bad. Alright. Now, next problem. The set of A is equal to -1, 0, and 1. So that's in the set of A. The set of B is equal to the set of 0, 1, 2, and 3. So those are the two sets with their respective elements of the set, with their respective members. We still want to find A in union with B. Well, look at both sets, look for the smallest number you can find, because you want to start with the smallest one. That's definitely -1. So you're going to get -1. Now, let's see, 0 occurs in both A and B, but you only got to list it once. So next you'll have 0. Let's see, 1 occurs in both A and B, but you only got to list it once. So you'll have 1. Then 2 and 3 both only occur in B, but you'll still have those since it's a united set. So the union of A and B gives you the set of -1, 0, 1, 2, 3. That's exactly what you would get. All right. Next problem. Set A has the members 3, 5, and 7. Set B has the members 4, 6, and 8. So right away, we notice that both sets have completely different numbers from each other. But we're doing the union of the set. In other words, we're taking A in union with B. So that means all you're going to do is combine the elements of both sets into one giant set. So start with your smallest number. You'll get 3, then 4, then 5, then 6, then 7, and then 8. So in this particular case, A in union with B gives you the set of 3, 4, 5, 6, 7, and 8. That's all you would get for that. So unions are actually pretty easy to understand. They're simple enough to understand. Intersections won't be that bad either, but they're different. Alright, set A only contains two members, 6 and 8. So set A contains two members of 6 and 8. Set B contains the set of 5, 6, 7, 8, and 9. So we have set A, which contains 6 and 8. Set B contains 5, 6, 7, 8, and 9. We still want to find the union of the two sets. So we're going to take A is in union with B. Now look for your smallest number between the two sets, because we got to combine the sets. That's definitely going to be 5. Next is 6. Even though they're in both sets, you only have to list it once. Then you have 7. Then 8's in both sets, but you only have to list it once. And then you have 9. So basically, you get set B back again, because everything that's in A is already in B, but nonetheless, we still have to do the union of the sets. You get the set of 5, 6, 7, 8, and 9. That's all you get. As we get further into, this will be in a different course, more into your number theory courses and set theory courses. You could actually have written A as a subset of B, but we're not going to get into all that today, because this is This is not a number theory course, even though I do have to introduce a little bit of it. The primary goal of this course is algebra, not number theory. Alright, 2 more problems for unions. Let's see, we have the set of 3, 4, 6, 8, and 12. So set A has elements 3, 4, 6, 8, and 12. Set B has 2, 4, 6, 8, and 10. So set B has members 2, 4, 6, 8, 10. Again, we're going to only right now stick with A is in union with B. A is in union with B. So, all you're going to do, once again, combine the elements of both sets together into one giant set. So, look for your smallest number between the two sets. That's definitely 2. That'll be an element of it. 3's next. Then 4 occurs in both sets, but you only have to list it once, so you get 4. Then you have 6. Though it occurs in both sets, you only have to list it once, so you'll have 6. Then 8 occurs in both sets, but you only have to list it once. 10 only occurs in one set, but we'll still list it because we're combining the sets. And same with 12, only occurs in one set, but we'll still list it since we're combining the sets. So the set of A in union with B is the giant set of 2, 3, 4, 6, 8, 10, and 12. You just combine both sets together. So that's the union of the sets. I got one more problem for union of sets. Then we're going to move on to intersections. Set A has the set of -5, -4, and -3. So that's set A, -5, -4, -3. Set B is going to be -2, -1, and 0. So set B has the set of -2, -1, and 0. Well, we still want to find the set of A in union with B. Since it's a union, we're just combining both sets together. So start with your smallest number. You'll have -5, then you'll have -4, then you'll have -3, then -2, then -1, then you'll have 0. So the set of A in union with B is the giant set of -5, -4, -3, -2, -1, and 0. That's all you would get. So unions, you're just combining sets. Think of it like you're uniting them. You're putting them together. So that's how you'll remember that. Alright, so that's it for unions. Now we're moving on to intersections. Which, those aren't that bad either. Those really aren't. So, let's see here. Intersection of sets. So now we need to discuss the intersection of sets. Denoted by, again, the set will usually go by a capital letter, the same as it was with unions. But this time you'll have A, it'll be an upside down U, almost look like a horseshoe, or you could think of it like an N for intersection. N for intersection. If you can remember that, you'll understand. N for intersection. It looks like a horseshoe, an upside down U. So it'll be A in intersection with B, B in intersection with C. What else? You could have A in intersection with C. And of course, you can do A in intersection with B in intersection with C. And yes, you can even combine problems. If you have more than one set, you can take, I could do A in union with B in intersection with C. But good news for you, we're not doing that today. There's no reason to do that today. So in future set theory courses, though, that may come up. But today I just want you to grasp unions and intersections. So this time, let's see, set A is going to be equal to, we'll go back to our original members here. 1, 2, 3, 4, and 5. Set B is going to be 2, 4, and 6. Then set C is 7 and 8. Alright, so this time we're going to focus on finding the intersection of sets when you have set A being 1, 2, 3, 4, and 5, set B being 2, 4, and 6, and then set C just being 7 and 8. Let's start A intersecting with B. So set A intersects set B. So when you do an intersection problem, all you're going to do is look for what elements of the two sets do those two have in common. So what elements of each set do the two sets have in common? Look at both sets. Okay, start again with your smallest number. Start drawing your set notation bracket. Well, do they have a 1 in common? No, it's only in set A. 1's not going to be an element of the set. But they definitely have a 2 in common. A and B both have a 2 in common. So 2 will be a member. Do they have a 3 in common? No, it's only in set A. How about a 4? Yes, they both have a 4 in common. How about a 5? Nope, 5's only in set A. How about 6? Nope, 6 is only in set B. So the intersection of A intersecting with B, that set is only the set of 2 and 4. It's only the numbers that the two sets have in common will be 2 and 4. So that's all you're going to get for that. Now next we're asked to find B is an intersection with C. Well, start with drawing your set notation. Again, look at the two sets. Do they have a 2 in common? Nope, 2 is only in set B. How about a 4? Do they have a 4 in common? Nope, 4 is only in set B. How about a 6? Do they have a 6 in common? Nope, only in set B. How about a 7? Do they have a 7 in common? Nope, that's only in set C. How about 8? Do they have an 8 in common? Nope, that's only set C. So, in that case, you get what's called a disjoint set. When you have no members in common, in other words, when the intersection proves empty, you get what's called a disjoint set. That's denoted either with set notation looking like a 0 with a slash through it, or you can also just simply draw a circle with a slash through it. That denotes an empty set, a disjoint set. So you can draw it with the set notation around it, or you can draw it without the set notation around it. Either way, that means a disjoint set or an empty set. So they have no elements in common. That's how we got a disjoint set. Alright. Well, let's take A intersects C. How about that? Well, look at A and C. Do they have a 1 in common? Nope, that's only an A. Do they have a 2 in common? Again, that's only an A. How about 3? That's also only in set A. How about a 4? That's only in set A. How about a 5? Only in set A. How about a 7? No, that's only in set C. How about an 8? Only in set C. So you get yet another disjoint set, or an empty set. That would be your answer for A intersects C. You would get the empty set. Alright, and last but not least, we're going to take A intersects with B, which intersects with C. Well, here's the thing. We know A intersects with B. We proved that that was a set of 2, 4, right? But B intersecting with C proved to be an empty set. So even if for one pair you got a result, if you try to intersect it with an empty set, you're just going to get an empty set. So if you try to intersect anything with an empty set, you just get an empty set for your result. So there's no answer to that. Now if you try to unionize something with an empty set, then you'll get numbers. You'll actually get values. Okay, so that's pretty much the definition of intersection. Now we're going to do 6 problems with intersections. We're strictly going to deal with intersections for these next 6 problems. So we are going to find A intersects B when, so see, A intersects B when we have set A having the members -2, -3, and then -4. Then set B will have the members -3, -2, -1, and 0. So those are your 2 sets. This time around, we are going for A intersects with B. We're looking for that set. So look at both sets. Again, start with your smallest number, okay? Do they have a -4 in common? Nope, that's only an A, so that can't be a member. It's only in one set. How about -3? Yes, both A and B have a -3, so that'll be the first member of your set. How about -2? Yes, A and B both have a -2, so that'll be a member of the set. How about -1? Nope, that's only in B. Can't be a member. How about 0? Still only in B. It can't be a member. So your set for A in intersection with B is just a set of -3 and -2. That's all you would get. So as you see, intersections aren't too bad either. It's just what elements do both sets have in common. Where union, you're just combining elements of both sets. That's all you're doing in a one giant set. But intersection, it's what do both sets have in common. Alright, next one. We'll have -1, 0, and 1 for set A. Set B will give you 0, 1, 2, and 3. Okay. Now we have both of our sets. So next thing we want to do is find the intersection of these 2 sets. You'll have A intersecting with set B. So since it's an intersection, think of the end for the intersection. You're going to find what elements do both sets have in common. So start with your smallest number again. Do they have a -1 in common? No, that's only in set A. That can't be a member. But they do both have a 0 in common, so we would start at 0. They both have a 1 in common, so 1 would also be a member. But 2 and 3 are only in set B, so those wouldn't be a member of the intersecting set. So the answer for the set of A in intersection with B is just the set of 0, 1. That's all you would get, the set of 0, 1. Alright, got 4 more problems, then we're done. Alright. So we have the set of 3, 5, and 7 for A. Set B is going to be 4, 6, and 8. So set A has members 3, 5, and 7. Set B has members 4, 6, and 8. Well, we want to find the intersection of these two sets, where A intersects with B. Well, without having to really do any work, we look at both sets and immediately notice they have no common elements. They have nothing in common. So you're going to get the disjoint set or the empty set. That's what you would get, the disjoint set or the empty set. That's all you would have, since they have no members in common. All right, 3 more. Let's see. Set A just has the members 6 and 8. Set B has the members 5, 6, 7, 8, and 9. All right. So once again, we want to find the intersection of set A with set B. Well, immediately we can look at set A and see that set B has both of those. And that's really all you're going to have in common is 6 and 8. So you just get the set of 6 and 8 for your intersecting set. So the intersection of A and B is just going to be 6 and 8. Then I have 2 more problems. All right. Let's see. We got 3, 4, 6, 8, and 12. Those are the elements of set A. Set B, you have 2, 4, 6, 8, and 10. All right. So those are your 2 sets. Now we want to find A is an intersection with B. We want to find that set. So start with your smallest number. Do they have a 2 in common? No. It's only in set B. That's not going to work. How about a 3? Nope, 3 is only in set A. That doesn't work. They both have a 4 in common, though, so 4 would be the first element of the set. They both have a 6 in common. That's the next element. They both have an 8 in common. That's also an element of the set. But 10's only in set B. 12 is only in set A, so those can't be elements of the set. So the set of A in intersection with B is only going to be 4, 6, and 8. That's all you would get. And it is possible to have a set with only 1 element. You will see that sometimes. Sometimes you can get that, a set with only 1 element. Or sometimes you get the disjoint set or the empty set where you have no elements that are common. Alright, I have 1 more problem, then we're done for the day. A is the set of -5, -4, -3, and then B is going to be the set of -2, -1, and 0. So again, we want to find the set of A intersects with B. Well, without having to look too hard, it's pretty obvious that both sets have no numbers in common whatsoever. So your answer is the empty set or the disjoint set, however you'd like to say it. Empty set, disjoint set, they both mean the same thing. So you get absolutely nothing for that. So you want to avoid saying 0 because then it looks like that's actually a number that's in common. You want to make sure when you're doing the empty set, you draw your circle with that line through it to denote the empty or disjoint set. So to review unions, you just take your sets and combine them together. That's all you do. Intersections, you're simply looking, think about it like an intersection on a road. That's where 2 streets come together, right? The intersection isn't both roads put together. Heavens no, that could go on for miles and miles. The intersection only refers to where they come together. So that's basically what elements do they have in common. That's all an intersection is. So next lesson we will get into combined inequalities, which will bring a little bit of set theory into it, but not too much. But we're going to get a little bit higher into inequalities in the next lesson. So I hope everybody has a good night. Take care.